we ask you to finish these two assignments right here. Finish problem 1 and B per line. And so now let's see our work. Now let's switch to Eclipse right here, and then open up. You put in assignment 1, right? Yeah. What's the name of the file? Collect a newspaper. So this here is basically in this world. You need to, starting from here, go out and pick out the newspaper. And let's see how this thing works. So we run this, right? So collect newspaper, Karel. And okay. So this is the word we're taking in, and then start program. Woohoo! It's finished.
Yeah.
Okay. So that's the first part of the assignment, which is finish problem 1 in assignment 1. And let's see the rest of this thing. So make your program works in rooms and world of different size. You can assume Karel always start from the northwest corner facing west, and the newspaper is always right outside the door opening. Have you tried that?
No.
Okay. So now imagine this room is a little bit bigger, like this size. We can actually edit it right here. So we can add this word, and then we can add walls right here. And then we can remove. Okay, now the room must be bigger a little bit, and then we put a beeper. Now we save this one, and we save it the same room. We give it a name. Or we can just save it to the same file. Okay, replace it. Yes. Now let's see. We finish this and run app, and then we run this again. So we run this again, and you will see that the room got bigger because we added it. We changed the word. And if you run your program, what will happen? It will run this place exactly where the beeper used to be, and then I try to pick up, and what won't work. So
Why does it have to have a wasp?
it's a bug. A
It
bug.
looks like a wasp.
The wasp is a bug. A bug is a metaphor for your program has
Yes,
a
I know.
problem. So that's a widely used word for programming program. So okay, so the assignment second one is that make your program works in rooms of different size. You can see that if at this step of the run, you can always assume that Karel is in this corner right here, facing east. And then you need to go forward. So the move is the right thing to do, but you don't know how long before you go. Because you don't know the size of the room. So in this case, in lecture 2, which concept will actually help you in this case? Yes?
While something is true, then you do something.
Okay. So have you taken a look at the while loop in lecture 2?
No.
Did you? Did you watch lecture 2 video?
Oh, so it's like
Lecture 2.
if you like move until you go to the end of the room and then
Yes.
turn.
Because here you move 2 steps, right? It won't work in the bigger or smaller room because the steps you take, you don't know. So the idea is that you want to write a program that is fitted for different sides of the room. So before you actually run the program, you don't know how many different moves needs to be here. So in that case, you need a while loop. The while loop will actually So Sophia, what do I write here? While some kind of a condition, and then you
Curly.
move. So you move until
You hit a wall.
you hit a wall. And what do we hear? How do we know we hit a wall?
Front is clear.
So while
Front is
clear, we move. And then we can see that what will happen in this case. So let's see, actually we stop this, and then we have a breakpoint here, and then we start this again. Okay, now let's see how the while loop works. We go step by step. Last time we talked about how do we. So this is, let's go to debug. And where's my debug button? Where's my debug button?
It's the bug. Like ladybug.
Just a second. I think I actually pressed the wrong button. Okay, let's see.
Just run it and then it will give you the.
Oh, I haven't started the program yet. So start program. Yes, and it will actually stop here. And while, so recall what actually you learned in the lecture, that the while loop work like this. So first is that it judge whether this is true or not. And in this case,
Front is clear, so it moves fine.
in this case, we can see that front is clear because there's nothing in front of Karel in this case. So front clear is true, and then it will proceed to move forward. So we'll proceed to move forward. And then it will go back to the beginning of this loop and judge it again. Now front is still clear and we move again. And then we repeat this step until this here, front is not clear anymore. Front is blocked. So in this case, what do?
We have to turn right, but there was a move under.
Oops, sorry, let's start over. So I pressed the wrong button. So let's start over. Start program. So again, let's. So now front is clear, and then we know front is clear. So let's move, and then after move, it go back to the front of the loop, and then judge it again. Front is clear, move. Front clear is move, and now front is not clear anymore. In this case, it will go to the end of this and go out of the loop because the condition is not true anymore. So now it's the next step, and this is we haven't touched that yet, but this is move, and when you do move here, because front is so basically it go to the other side. So now you know that when you don't know the number of steps you need to take, instead of stacking several moves, you need to use a while loop. Use a while loop to go forward until you cannot go anymore. So that's how the while loop is connected. That's when you adapt to the word that you don't know how big it is. Now you go to the right corner of the word, and what should you do here? Delete that,
right.
And then we turn right, and now we're facing down. And what should we do here? Again, you don't know how many moves that you need to take. So what do we do here?
While front is clear, you can move. You can do that. Oh, but then you go past the doorway.
Yes.
Oh, yeah. So
yes.
If left is clear.
Yes. So that's a very good observation. We actually also replace this with one move with a while loop, since you don't know how big the world is, but you cannot use front is clear because you cannot go forward until you hit the wall. That way you pass the doorway.
And then you keep going.
You keep going. So you don't want to pass the doorway. So instead of front is clear, so when you're facing downward, and the doorway will be on your left. Okay.
But then when you're in the corner, then won't you not move because there's that door, like a wall next to
Okay,
you?
so sure, just a
No,
second.
if
This
left
block.
Wall left is blocked.
Yes, that's my mistake.
Yeah.
It's blocked. And then we move, and now we can see that we must be at the, when we finish this loop, we must be at the doorway, right?
So
because if this is true, we'll keep executing this loop. When we finish this loop, the condition must be false. So which means that the left is not blocked anymore, and then we turn left, which means that we're facing the doorway, and then we move forward and pick beeper, and then we basically, this is turn around, and then again we have several moves. So this needs to be replaced with another while. And tell me what condition to put in here.
Front is clear.
Front is clear. Cool. And now we actually goes to, oops, sorry. My keyboard has some problem. Okay. This keyboard is stuck, so and then we turn right, and then we do that again. We copy this, and then I paste it. Okay. Do you think this will work?
Yes.
Okay, let's see whether this will work. Collect newspaper Karel. Now we may not need this anymore because we pretty much already saw that. So we start program. Woohoo! Yay, it worked! Okay, let's try another one. So basically what I ask you to do again in this assignment is I have a bigger word. So let's try this one. This is a bigger word. What? Why do I need a
Didn't you already download it to this computer though? Just log in. Oh, sure.
don't want to log in this one. So but anyway. So
Oh, yeah.
So this is actually available to everybody, but anyway. So now we can test it using that word. How do we test it using that word? We save that word into the download directory, and then we run this program again. We run this program again. Before I hit start program, I don't want to use this word. I want to use another word. So I load word, and then I save it into the download directory. So let's see the download directory, and this is yes. Okay, so this is a bigger one, much bigger. And do you think this one will work?
Yes.
Yes, because our program doesn't care how big it is. We look before we go. So the Karel has eyes to see in front of him, or back or left. And then we use that information to judge when do we take action. Yoo-hoo! So that works. Okay, so that's the end of the first assignment. That we actually make this work, and this is general. Okay, beeper line. Run beeper line project in Meet Karel tries to line the bottom of the board with beeper, but it failed. What went wrong? And did you fix that?
Well, now I know how. I have to put like while front is clear, right? Until
Okay.
you get to the end.
Just a second. So let's open our Eclipse, and then this is in Meet Karel. And then what this is a beeper line program. So we basically look at 4 of them and then put beeper and try to move. And then so we
But you can't do while front is clear. Something else because if front is clear, you have the corner, you still have to put people.
okay. So
While front is clear, and then add another banner.
so I put a oops, what did I do? I put the breakpoint here, and then let's see what the action will look like. So it says start program, and then remember this is a for loop. The lectures introduced a for loop which execute definite amount of time. It cannot adopt as a while loop. Later you will see actually the for loop can adopt as well, but in this case the for loop doesn't stop. So basically it will just executes 4 steps, and each 4 times, and each time it will do put beeper and then move, and the second time put beeper and then move, put beeper and then move. Now a put beeper, this step is actually okay because you can still put beeper, you cannot move.
So Karel has a bug.
So now we have a bug. So how do we fix it?
They went too safe way.
You missed the first assignment, but I already recorded this, so you can go back and take a look at what we talk about. Or you can actually stay after this, and I can go through this thing with you. But anyway, so let's go back a little bit, and now we're talking about the beeper line, and so this project right here. So the beeper line project Meet Karel, and this thing has a bug, and I'm asking you what's a bug and why it's actually. So we just went through this. That we have a for loop here which executes 4 times. Each time it will put beeper, move, put beeper, move, put beeper, move, and then the 4th time it put beeper, there's no problem, but it cannot move anymore because it's blocked. Now the program crashed because you cannot move anymore. So Karel is blocked, you cannot do that. So the question is that how do you fix it? What's your suggestion of fixing it?
Okay, so do while beeper, while front is clear.
Okay.
Delete that.
So you replace this while and front is clear.
And then do put beeper and move.
Excuse me?
Put beeper and move.
Put beeper and move.
Yeah.
So that is that right?
Yeah. And then at the end, add one more. Yeah.
Why do you need to do that?
Because it can't put the beeper and move at the end because the front's not clear.
Very good observation. So
Okay.
very good observation. So here that if you just put in here, you will notice the last one won't have any beeper. Because then the last one, this is false. So let's actually do this. Run this and see what will happen. So that's a very good observation. Let's see. So we start this program, and then we front is clear, put beeper, move, front is clear, put beeper, move, front clear, put beeper, move, and front is clear, not clear anymore, but we still have last one to patch. Good observation. Okay, now we finished it. So let's go to the next step of this thing. Make beeper line works on different sides of the word. Test your solution on existing word on the word directory of radio. Okay, let's try to do that.
It should.
Do you think it should work?
Yeah.
Yes, why?
Because since the front is clear, no matter how long it is.
Yes, because it didn't decide. You didn't decide how many steps it takes. It just watch as you go. So this should work. Okay, let's verify our hypothesis. So instead of using this board, let's load some other big ones. My keyboard is not giving me a good time. So let's just pick one, and then this search 7 by 7. Okay, pretty big. And so let's start. Stop again. Okay, let's remove this and just see this works. Continue. And then this means that resume, it will just run through again.
Yay!
Yay, it worked. Okay. Now extend beeper line to beeper on 4 edges of the word.
I didn't do that. I didn't do that.
Let's do it now.
But you maybe do something else. The one with the every other people thing.
Okay, but let's do it now. Okay. So since nobody did that, let's do it now. Okay, so go back to this and stop this. So what do you think should do? This one will align the bottom. Let's assume that the Karel always starting from point 1, and facing east. But instead of going through the bottom and align the bottom with beeper, you want to go all 4 edges and line all the edges with beeper. How do you do?
Okay, so can you put like repeat 4 around the whole thing? I don't know what it's. Yeah, 4, and then int.
4 times?
Yeah, because all worlds have 4 edges, right?
Yes. Yes. Nice observation.
So, okay, and then
Just a second.
turn.
Let's put some indentation in here. Yeah,
You could highlight the whole thing and press Control F.
yes, I should do that, but anyway. Okay. No, not Control F. Something else. But anyway, so this is what you want.
No, and then at the after put beeper at the end, put turn left. Yeah.
And
Oh wait, there's gonna be a repeat at the very end.
yes.
Oh, so then 3 times. Because it's gonna go this way, and then there's another one here because it puts one in the very beginning and one at the very end. Oh. Okay.
There are several solutions.
Just do it 4 times. Well, beeper, if beepers aren't present.
So what should I change here? Here?
The bottom one, you know.
Okay. So change here. So if what's that again?
No beepers present, I think. Oh yeah. There's a whole list. I'm not sure. No beepers present. It's beepers. There's an S. It's very important. One little better.
Cool.
Hopefully. I probably too stupid.
Anything else?
I hope not. No. You have to put the brackets around it.
Yes, that's a good observation. But this one works too. Just so you know.
Oh.
So the one, so basically the syntax of Java is that you have a condition, and then you have one statement that follow this condition. This is only one statement.
As long as it's one statement.
Yes, because bracket makes multiple statement a compound statement. So the meaning of bracket is basically combine all the statement into one. So the syntax of if or for or while is that the condition followed by one statement. But what you said is actually a good practice. Always put bracket around it. For the reason that we will actually study in the later chapters. So let's see whether this works. So we need to save this file. And then it's slowly building this. And then we don't want to use a small word, we use some other bigger ones. So okay, let's pick a big one. Let's pick
That's
huge.
huge.
Okay.
I can't read. You
So-
can't see Karel. All I can see is Karel's eye.
It looks like a triangle.
It looks like nothing.
It is a triangle. It's a
It's
weird
a pentagon thing. You
Okay,
can't see
so let's see.
at
Start
all,
program.
really.
Wow.
Good job, Karel. Good job.
So let's run it slower.
No, there's like 2 on each corner though.
Oh yeah.
Oh
Who
Oh,
cares?
There's
There's
it's turn left move.
Oh.
Okay, nice observation. There are 2 in each of this
I'm
corner.
surprised I could see that, to be honest.
So you actually screw up. So how do we change it?
I don't think we just do turn left and then move. I
Let's
guess it
try
should
that.
work.
Okay, let's try that. Where's my cursor?
It's there.
I always have trouble. So turn left and then move. And now imagine what will happen. And then tell me whether it's okay or not.
I don't have
Okay, I'm just gonna like run through this.
think it'll. I guess it will.
Okay, let's
It looks
Yeah, I
like
think it'll work.
let's try that. Let's try that. We can always try that.
Yeah,
The wonderful news of computer programming is that you can always try, right? It doesn't hurt to try multiple times, and trying is always the right way to see. Experimentation, at least. So let's run this. Start.
It didn't end up in the same place unless you wanted it to end up in the same place it worked.
Yes. Okay. So I didn't specify that in my requirements. So this actually works. Let's try it in a different word. Why I always have trouble finding my cursor?
Because you're sitting to the side.
Okay, let's try a different word. Not so ambitious, but still. Cool.
Yay.
Okay. Now,
Oh, wait, at the end you can fix it by like
Turning
if no
around.
beepers where you are or something.
You can read.
okay, so you're saying that we should actually make some change to make this even better, so that it won't go over.
You could just turn around and move.
Yes, that's one solution. Yes, and what you're suggesting
Oh,
is
okay. For like the move, do if like what's the command for no beepers in front of you?
If no beepers.
There's no thing before in front of you.
Just present.
Yeah, there's only present. No beepers in front. I don't think that's.
there's yeah.
There's no.
Unless you actually
No,
move
but
forward
if you
and
do-
then find that there are already beepers and then you move backward. which is essentially what she suggested.
No, I told you to turn around and move back because you're always off by 1.
Yes,
No matter
that,
how.
that,
So it's
that
turn
works
around,
too.
move, and then
Okay,
you turn
so,
around again, just in case you want us to face east too.
Okay, but anyway,
around,
let's
and
go
then
back
turn
to the
around.
requirement.
Yeah, or move backward, but there's no such thing.
So the beeper project in Mirror, does it actually say anything about the?
No.
Okay,
It just says
so it's
no
not in the requirement,
Yay.
and okay, we consider this done. Okay, now we do this. So this actually is a little bit about telling you what extends mean. So you all see this. All this program has extend, and this one extends SuperBadKarel.
They all extend SuperBadKarel.
And this one actually extends Karel.
Because that one's the first
So
one.
the lecture, I don't know whether you remember the lecture actually mentioned this. The Karel only knows how to turn left.
Yeah,
Yes.
it can't turn
And
right.
then it cannot turn right. So if we actually see,
Wow.
so this is a beeper line. If we say instead of SuperBadKarel, we say Karel, it will still compile. But if we want to call right,
It's not gonna do. It's gonna
it won't do it.
Register.
Yeah, it's the compiler just tell you that it's not defined. But if you actually
change it to
SuperBadKarel. Okay, why is that? Because SuperBadKarel is a special kind of Karel which know more than Karel do. So when you extend SuperBadKarel, you are building a kind of special kind of a SuperBadKarel which knows whatever SuperBadKarel knows what to do. Okay?
Yeah.
So here, in this assignment here, I want you to create yet another kind of a Karel called SuperBadKarel. That is yet another special kind of SuperBadKarel, and it knows something that the SuperBadKarel doesn't know how to do. So basically, each method you decide you implement here will teach your special SuperBadKarel to do something that his ancestors doesn't know. So he can bigger and better and more super. So so let's see how to do this. So basically we can walk through this and we can create a class. So you right click on here and then new class. And this thing is called SuperBadKarel. And then you can just use this. It doesn't matter. Just finish.
Boy or girl, that's because.
And then we need to actually.
Carol can be a boy. Well, Carol for girls.
We need
like
this. We still need
yeah.
this. For the reason that you will actually go over your lecture videos and find out. And then, so as we talk about in the web page, here we extend SuperBadKarel. So SuperBadKarel, remember SuperBadKarel knows how to do a whole bunch of things that the Karel doesn't know. And now we want to introduce another super kind of a SuperBadKarel, which know a bunch of things which.
I tell you how to do.
So this basically means that I want the Karel to go forward until it's it's blocked.
You spelled until.
What?
Until
Oh.
you tell. It doesn't matter here because it's your command as long as you spell it the same each time.
Yeah, but it's always a good practice to spell it correctly. Yeah. Thank you for that. So what do we do here? Your turn.
See until what?
Those two should know because we just did that, right? We just did that in the pick newspaper, right?
Yes.
So this assume that you don't have anything in front of you and you move and until you cannot move anymore.
Wait, which program is this for?
I don't know.
You're making a new.
I'm just telling the some special things that SuperBadKarel should be doing. So remember in the lecture that they have the example that when the Karel only knows how to turn left, and you want it to be able to turn right. So you define a method which calls it turn right, and inside it says turn left 2 times.
3 times.
Three times. So that's what it's for. So this is a special kind of action, a higher level action that the Karel should be able to do.
What was the other command like? Was it like keep proceeding? Or no? It's.
Okay, so let's go back to this and remember that we have a collect newspaper Karel.
Say wall front is clear, move, and then move. Yeah, it's just wall front is clear, move, I think.
Okay, so this is what we do.
Yeah, it's wall front. And then add move. No, you don't have to. Because if you move again, because your one space, the wall's here, your front is clear, so you move. If you add another move again, you'll bump it. It's just.
We can actually it's also on the assignment. You can test it. So basically, the way to test it is to create a run method. So void run, and you're familiar with this, right? And then we can actually say call per and then we can actually create a SuperBadKarel. It's by default actually loaded something. But anyway, so let's see. Start the program. We'll call this proceed until blocked.
Yeah.
Does it do what I will ask you? Yes, it does. Okay, so that's the first one, and then we turn east.
This one's annoying.
So we don't know, the precondition is that we don't know which way Karel is facing. We wanted after this that Karel should be facing east.
She's this way.
Yes?
So you can do like if facing a certain direction you have to turn a certain way in order to get east. So if like you're facing north, you have to turn right in order to be facing east, and then like same for all the other directions.
So basically you need to have 4 branches.
No, you only need 3 because when you're east you
don't do anything. Okay, if you're facing north,
bracket, turn right. Yeah. And then if you're facing west, you turn around. And if you're facing south, you turn left.
You basically
Facing
need
north.
3 branches. I got the idea. Is there any other idea?
But does facing north exist? Yeah. If it's like it tests like which one.
So it doesn't exist.
Yeah.
Oh, okay.
That's why there's no red squiggly line.
Then, like, so that's all.
So the way to check, quickly check whether this thing actually exists is that you can click on this one. And then right click and open declaration. So this is, you don't have the source file, but this has some information telling you which one is actually exists. So all this public thing exists.
You can make it different colors.
Yes,
Make
you can make it colors.
Carol?
And they have
I
a
don't
round
know. It
method
just said
and
color
you have
black,
turn right.
color blue.
You can see they have turn right, and then they have turn around. They have turn around,
Whoa, that's a lot of code.
and then there's a paint corner or something. I'll send you a PDF file containing all this information. I think I had it, but I forgot it
Wait,
to put it in the web page.
is it
Oh.
this one?
Yeah, I guess it's that one. So so this one is that. But anyway, here the turn east. Can you think of another solution to do turn east?
That's what I
If facing south, turn left.
Yes, but then I know. So
Another
basically,
completely different idea.
so instead of using 3 branches, you use only a simpler program to do that.
I think I know.
Okay, go ahead.
If not facing east, turn right, and it'll keep doing that until it's facing east.
Okay,
Right.
so how do I implement that?
If not face, is that a thing?
That is actually a thing. Good.
Yay!
So
Makes
If-
life easy.
if not,
Yeah.
not is
See,
this is not. This means not.
you can also type the word not.
I'm not sure about that. But anyway.
It says right here.
Okay, so facing east.
Exclamation.
Does it work?
Yes. N-O-T. It does. It's a thing.
No, I mean
Oh.
is this program works?
No. Because then, like, if
Yeah.
they're
Turn left?
facing like west or something and they turn left, then they're gonna.
Oh,
Yeah, so-
is it while?
Yes, it's wild. Does this work?
Hopefully.
Yes. Yes.
Yes, it works. Okay, but anyway, so I'll actually let you finish all these. The point of this, rather, is to tell you that how to use these things. So now you basically have a special kind of Karel which have this thing, and then you can use this bad Karel stuff. Now, how do you use it? Well, how do you use it? So, well, we actually have, and we copy it here. So basically, we make a copy, and then we paste it. So we have a SuperBadKarel in this folder. And the reason I want to copy over this is that we want to utilize what we know in here. So here you realize that there are several things here, which means that you just want to go forward until you hit a wall. And then you want to be able to use the method you just created. And then here you want to replace it with
Proceed until blocked.
till block. Does it work? No, because SuperBadKarel doesn't know how to do that.
So yeah.
Only SuperBadKarel knows.
Became super duper.
Yeah, you can name it any way you want. So SuperBadKarel all of a sudden works, and let's see whether this program works.
SuperBadKarel. Then you can make another SuperGirl.
That newspaper.
Super dog. You don't have to even put the super in.
Okay, let's load a bigger world.
You even have to work.
Yeah. You can just make it plainly like book.
Or A,
Oh,
B,
the
C.
thing has
Carol mop.
died on me again.
You could make it A, B, C. So you can make
Why
it big.
Why
I'm
is
city.
this thing died
A,
on
B,
me
C,
again?
D, E.
Carol died on me. Load wall. This piece. Okay, so this is a bigger world, and see whether we can start program. It works as expected.
Yeah.
So this idea of this is assignment here is basically telling you that in certain situations like this, when you want to repeatedly do one thing, you may want to teach your Karel a special kind of skill. And in
Then
this
you can
case,
use
the skill called proceed until block. And you can put those skills into a class. And then later you can use that class by extending that. Okay? So I guess that's today's lecture. That's today's class. And but before I'll let you go, and I'll need to emphasize several things. What you do next time we come here. So go to our webpage, and then we talked about the basic construct this time, and next time is decomposition. And first of all, you need to watch lecture 3. This is a video, and I want you to go over it several times, not only one time. This one is actually a bigger project. This is harder than what we have. The first and this meeting we had is basically an introduction, which is just see the door. And now we're getting into the real stuff. And I expect you, any one of you, at least spend 3 to even 6 hours on this thing. And so programming assignment. Ideally, you should be able to finish all these, but I think this is maybe actually too much. Try your best to finish this part, alternative line. I know that's a lot, and that's why I said that you need to spend quite some